FeOS2. So FeOS2, this is not act as a coagulant. It requires to oxidize it into ferric iron by oxygen, by dissolve oxygen in water. Now S2O, this one is the oxidized, and the oxygen that is taken by the dissolved oxygen is used here. Converting of this one, so this one is act as a coagulant. This one is act as a coagulant. But here the formation of this one, so this is not act as a coagulant. Now another thing. It is necessary that before we use the coagulants, that is necessary to control the pH. So alum sulfate, alum is used as a coagulant when the raw water pH in between 5 to 7.5. pH ranges in between them, then we have used to alums. Why? So this is one thing ki when you remember this one, ki when we are using a aluminum sulfate, so there is the formation of a one product that is H2SO4. If the pH is lower than 5, so that it means pH that should be reduced. So that is not suitable for a drinking purpose. So that's why the pH that should be maintained to lower pH is 5. If lower this pH, so we are not using as a alum or aluminum sulfate in this water. And why this one is the maximum pH is 7.5. So if the greater the 7.5 pH, so aluminum sulfate is forms aluminate. This is the one of the reason. If the higher the pH, near about 8, so aluminum hydroxide, this one is forms a sodium aluminate. Sodium aluminate is formation, and this one is suspect for a carcinogen. So that's why we have not used the aluminum sulfate above from this pH and lower from this pH. Suppose in some water, raw water, there is the if the pH is low, so what we are using? So then we are adding a calcium bicarbonates with the alum Al2 SO4 thrice clean H2O. So then there is the formation of a OS3 plus calcium sulfate. CO2. So this is the complete reactions, the formation of ammonium. But there is the another problem, that is the formation of a calcium sulfate. So calcium sulfate, this one is the permanent hardness, causing for a permanent hardness. So thus the raw water hardness that should be increased in this one. And another CO2, that is leads to corrosion. So these are the two demerits. If the water has low alkalinity, so lime is added to water. Suppose there is the alkalinity is low, so there is the use of a calcium hydroxide. So when the calcium hydroxide is used, so there is the formation of a ammonium hydroxide plus calcium sulfates. So when the formation of calcium sulfates, so that it means that should be increases the permanent hardness. There is the another process. We are using a both ferric sulfate and ferrous sulfate. Both are mixed in the flowing reactions. So effectively they act as a flock. And it is in that should be used in a separate form, or that should be used in a combined form. So when they are used as a suppose separate, so FeSO4 thrice plus calcium hydroxide, so there is the calcium sulfate and ferrous hydroxide is there. FeCl3, suppose we are using the calcium hydroxide, so there is the formation of a CaCl2. So again the hardness, permanent hardness, that should be increased of the water. Another steps is flocculator. Hello.
Yes, sir.
Okay. So flocculator is used. So what is the flocculator? So this is the mixing of the coagulants and water. So there is this structure is, this is the tank, and in this tank these are the paddles which is gently mixing, slightly moving on this one, so that the water and flock chemicals they are mixing properly. And if the mixing is faster, so that should be breaks the flock and the water combination. So that's why very gently mixing in this one, so that that should be mixed up in this one. Then the water that should be goes in this tank, in this tank. Another there is the pedal is there. So these pedals again that should be mixing of this one. So this is the mixing, and after that when mixes, so that should be comes into a settling tank. So here the settling tank, in this one, the water reduces the flow rate and increases the time. So this is the overflow channels. Overflow channels. So thus that should become in sedimentation. This one is the. So here the particles they have settled down due to the gravitational force. Now another thing, filtrations. If you have remember this figure, flocculation basin, mixing of this one, settling tank, then after filtration, sand filtration is there. So sand filtration, basically this one is the two types. One is the slow sand filtration and another is the rapid sand filtration. Slow and rapid sand filtering. Sand filtrations. So these are the what are the slow and rapid. So basically this one is it depends on the water flow. Slow sand filter. So this is the traditional. The peoples they are using this methods in a longer times. In the upper part, there is the water that is kept, and in lower so there is this some sand and gravels. Gravels. So thus the water that should be comes and collected from here by this one. This is the porous. These are the because these are the gravels. So size that should be increases in the bottom side and in the lower side, and the smaller side that should be in upper. Then after there is the smaller small particles is there, that is the sand, and above this one there is the water is filling. So this is the slow sand filtration. But rapid sand filtration, so this is the different types of the rapid sand filter. Open type mechanical filters. So this is the vertical structure of this one. There is the stanner is there. Then after this is the and the water flows. In this one. So by this one, there is the sand that should be filled up, keep in this cylinder, and the size of the sand that is increases to the lower bottoms. So this one is it. So this is the one of the water that should becomes in a rapid pressure or in a high pressure. Then after that should be passes through these sands, and when that is passes here these sands, so that should be removes the smaller particles by this one. There is the another type of this one, that is the horizontal close process filters. Horizontal this one only for a structure. So this one is the horizontally that the water that should be passes here. In this one the sand that is in this area, and then the water passes through this one. So whatever the smaller particle that should be removed here. There is the two bed filters, multiple mechanical filters. So these are the different rapid sand filters is there. So only the water that should be comes in a high pressure. So that's why that the process that is rapidly and The filtration is fast here. So this is the one of it. So this one is the filtration system. Another is the sterilization system is that disinfection. Suppose you are seeing here sham filtration and then after disinfections. So disinfections by there is the different processes there. These processes basically precipitation methods is there. So precipitation methods, so that should be water that should be evaporated and then after that should be converting into after the cooling that comes in a precipitate form. So that should be removes the impurities is there or microbes. Aeration is another process is there. So in the aeration, basically the water that should become spray or flow in the air. This is the water inlet. Water inlet, and then after the water, so there is the addition of a due to the that should be comes in a atmosphere. The addition of a oxygen is there much more. This is the spray like structure. All of you see this type of spray in a ponds or any reservoir, basically in this one. So water that is to spray forms is there, so that the oxygen addition of a oxygen and whatever the suppose thermal pollution is there. So when that should be spraying in the atmosphere, so heat it reduces here. Ozonization is the third of them. Ozonization. So in the ozonization process, all of you use the drinking bottles. So there is they mentioned that this one is the ozonized water. So what do you mean by ozonized water and how that should be ozonize the water? So this one is the very simple process is there. Electrodes and the voltage supply that is 20,000 volts that should be supplied in this one. This is the electrodes is there and the air that should be comes in the tank. So then after that should be oxidized and converting into it air plus ozone. So that should be. So this ozone that should be bubbling in the store tank where the water that should be stored in this one. So bubbling of this ozone is there. How this should be converting? So this is the twice O3, suppose ozonized water. So then after that should be breaks into it oxygen gases is there. So this is the ozonization, ozonized water. This is the process of this one. And due to this one, there is the liberation of nascent oxygen, so that should be control the microorganisms. Chlorination is another process. Because the chlorination is cheap. So chlorination is what? So when the using of a chlorine, it may be it is a gaseous, it may be it is a solid forms or liquid. So Cl2 plus H2O, so they have forms a hypochlorous, HOCl plus HCl. So this one is hypochlorous and again hypochlorous, HOCl, HCl. They have liberated the nascent oxygen. So this should be control the microorganisms in this one. Bleaching powder. In some cases, we are mostly using the bleaching powders because this one is the very simple and cheap. So bleaching powder, CaO, Cl2. This is the CaO, Cl2 plus H2O. So there is the formation of a calcium hydroxide plus Cl2, this chlorine. So Cl2 plus H2O. Again there is the formation of HOCl plus HCl. HOCl that should be breaks into HCl and nascent oxygen. So this should be act as a. So using the bleaching powder, there is the different types. In some cases, when we are using a chlorination, so what are the factors we are saying in this one? So turbidity is a turbid water, that should be not we are using a turbid water. We are giving some time allowed to sterilization, temperature of the reactions. This one is the quantity of oxidizable material. These are the bacteria, microorganisms present in water. If the higher contaminations of the microorganisms, so using the chlorination or dose of the chlorine that should be increased in that water. How much time we are giving, because without time when we are giving the time, so that the microorganisms they are removed from this one. So these are the what are the most important disadvantage of using bleaching powder. So it exists in water, causes unpleasant odor, and the water taste is disagreeable. It introduces a calcium hydroxides in water, so water becomes hard. What is the advantage? Because the price based on the quantity of available chlorine from it. So when the amount of chlorine liberated from a sample of bleaching powder, so excess of dilution, HCl, that should be increasing. So this is the demerit of this one. Now suppose bleaching powder CaO, Cl2 we are using. So there is the presence of a, when the excess presence of H2SO4. So this one is reacts. Because bleaching powder when we are using to be dissolved in HCl. CaO, Cl2 plus H2SO4. So there is the formation of a calcium sulfate. So this one is the hardness is increased, permanent hardness, plus H2O plus Cl2. So this Cl2 is called a available chlorine. Available chlorine. And again, this chlorine that should be reacted with the water, then there is the formation of HOCl, hypochlorous acid. Suppose the percentage of available chlorine in bleaching powder, that should be decreases on a storage. When we have stored the waters after the chlorination, so that should be slightly decreases. Why this one is the? Because Cl2, there is the formation of a another is the Ca. This is calcium chloride formation of this one. So that's why the bleaching powder concentration that should be decreased. Hypochlorite has also been used as a sterilization of water. This one is the suppose CaCl2, then after formation of a calcium hydroxide, then calcium hydroxide plus twice HOCl that should be used as a nascent oxygen. So this is the main reasons, the formation of this one. So that's why the bleaching powder or chlorine concentration that should be decreased in the storage tank. Forms of chlorination. So this is the plain chlorination, pre-chlorination, post-chlorination, double chlorination, super-chlorination, breakpoint, dechlorination. So these are the different forms of the chlorination. Suppose plain chlorination. So plain chlorination means only chlorine treatment is given to raw water. When we are keeping raw water, so raw water is that we are using a chlorination of this, and then after the treatment, that should be supplied for the water. So this one is the depends on the basically that is the how much water is contaminated. Pre-chlorination. So before treatment, we are addition of a chlorine. So this one is the pre-chlorine. Post-chlorination is there. After the treatment, then chlorination is there. We have used as a chlorine. Another is the double chlorination. So that it means both raw water and after the treatment, then after chlorination is there. So that is called a double chlorination. So these are the different methods is there, forms of the chlorination. Another thing, breakpoint chlorination. So breakpoint chlorination, just understand to this one what is breakpoint chlorination. So chlorination of water to such an extent that not only the living organisms but other impurities in water are completely destroyed is called breakpoint chlorination. Breakpoint chlorination. So this topic we have discussed in the next class, not today because your time is over. So we have here close this session, and in next session we start the breakpoint chlorination. Okay.
Okay, sir.
Okay. So now we end the meeting.
Thank you, sir.
And thanks to all of you.